Okay, so we continue on. So number four. We're talking about simplifying complex rational expressions. Right, so we're going to be simplifying complex rational expressions. Number four. Right, so here's our first problem for A. We want to simplify 1 over x squared minus 1 over 64. All of that is going to be over 1 over 8 plus 1 over x. Right? But I prefer, since the numerator starts out with something with x, I want to just write 1 over 8 plus 1 over x as, it's not that way in the original problem, as 1 over x plus 1 over 8. All right, so now there is some thing that you might have learned in elementary school or middle school called the butterfly method. And this is going to come in handy if you know that way. So if you want to think about it, what you're basically doing is the butterfly method. We're not going to use it explicitly, but we're going to refer to it. The butterfly method basically says that you multiply across this way, and then you multiply the denominators. Same thing here, you multiply across this way, then you multiply the denominators. All right, but what I'm going to do instead is I'm just going to multiply the numerator by this product. So I'm going to multiply this numerator by the product, 64x squared, right? So I multiply x squared times 64, and I get 64x squared. And again, the motivation for this is something that we used to do in middle school called butterfly method, or elementary school. I'm not doing the full butterfly method here. I just want to get the product of the denominators from that. Now, you should be able to see that 8x actually is a factor of 8x is a factor of 64x squared, right? So you use the bigger factor as the multiplier. So while 8x squared is a factor and 64x squared is a factor of itself, what we want to do is we multiply by the bigger denominator, right? Or the bigger factor. So the bigger denominator here is going to be 64x squared. I'm multiplying the numerator by 64x squared and the denominator by 64x squared. All right, got that? So let's go through the process now. Why am I multiplying by 64x squared? Because it is the bigger of the two denominators. So again, I have 1 over x squared minus 1 over 64. The numerator and the denominator, I'm going to have 1 over x plus 1 over 8. I just use the commutative property to switch them around. And so I'm going to multiply by 64x squared. I'm going to write that as 64x squared over 1. And I'm going to write it as 64x squared over 1. The next problem, I won't do the over 1 thing, right? So I'm showing you why I'm doing it, because I'm going to be multiplying everything by 64x squared over 1. So what I get here, and we'll do this a little longer, next problem is going to be shorter. What I get here is 64x squared over x squared in the numerator minus 64x squared over 64 when you multiply fractions, you multiply numerator by numerator, denominator by denominator. And what I get here in the denominator is 64x squared over x and 64x squared over 8. All right, and so I'm going to do this long way to explain what's going on so you kind of know where the information came from. Then I'm going to do the shortcut afterwards. So x squared into x squared cancels itself. 64 into 64 cancels itself. So what I have left here is 64, and I have an x squared. Now, same thing here. I have x into x squared leaves me with an x. 8 into 64 leaves me with just 8. All right. So what I'm going to have now, in the end, I need to erase this in some worst space. What I'm going to have is that this complicated thing is going to basically be 64 minus x squared in the numerator. And the denominator, I'm going to have, I see. I'm going to have 64x plus 8x squared, all right? So I kind of see why they wanted us to stick with it in the other direction. So I'm going to rewrite the 64x plus 8x squared as, 64x plus 8x squared. Let's just keep it like that. Keep it like that. Brain is working too fast now. All right, and so I'm going to have to do some factoring. Don't worry, I'm going to do this problem a second time. Slow down. You're getting this in real time. So what I want to factor here, this factors to be 8 minus x times 8 plus x. I know it's a little tricky. How do I know that? Well, if you think of this, 8 times 8 is it's a difference between squares, right? So the difference between squares tells us that a squared minus b squared is equal to a minus b times a plus b. That's what difference of squares tells us. Okay, it's a concept that comes up in high school algebra. And so what I have here is my A is 8, right? So 8 times 8 would be 64. And if you notice here, my B is going to be x. X times x is x squared. That's where I got that from. And now I can factor out an 8. And what I have in here, if I factor out an 8, I'm going to have, I can factor out an 8x. All right, so I can factor an 8x out. And what I'm going to have in here is I'm going to have an 8 plus x. All right, so factoring 8x out, I'm going to have 8 plus x. And so the 8 plus x cancels out. And what I have is my answer is going to be 8 minus x over 8x. All right, I'm going to go over this again, okay? So what I have here is going to be 8 minus x over 8x. The answer is indeed correct. I want to go over this one more time. All right, so we're looking on what was that? That was 4a, right? Let's go over this again one more time. 4a. There's a shortcut. So 4a, I have 1 over x squared minus 1 over 64. And I have 1 over 8 plus 1 over x. So if you multiply the denominators of these two fractions, that's another way to find an LCM. Multiply the denominators of these two fractions. 64 times x squared is going to be 64x squared. Use that, because if you multiply this, you're going to get something smaller, which is going to be 8x. So I'm going to have 64x squared as my multiplier. And I have to do the same thing in the denominator. All right. So when you multiply now, you're going to get this 64x squared is going to kill the x squared in the denominator. So that's basically going to give me a 64 here. And the 64x squared is going to kill the 64, so that's going to just leave me over with the 1x squared, right? All right, and so that's what I have on the top. And the bottom, the 64x squared, let me rewrite it. So the 64x squared is going to kill one of the factors of 8. So I'm going to be left with an 8x squared. And it's going to kill one of the x. It's going to kill one of the x's. So I'm just going to have 64x left over. Again, this is the whole process of canceling, right? And so what I'm going to have now is this is going to become 8 minus, and get rid of that 1, x times 8 plus x over, I can factor out an 8x. And I'm just going to have x plus, I'm going to have a factor of an 8x, I'm going to have x plus 8. Right? But we know that x plus 8 is the same as 8 plus x, right? So that cancels out. And what I have here is going to be 8 minus x over 8x. All right? Okay. So that's that. One final approach. I'm trying a lot to make sure this problem goes across, gives you an opportunity. I want to try one final approach, one more way to do this problem. So we're back to 4a. Another way to do this problem is to go through the butterfly method directly. So I kept on mentioning it, but I did not do it. So 1 over x squared minus 1 over 64. And I have 1 over 8 plus 1 over x. What the butterfly method is based on is this simple idea, let me write it on the board, mathematical idea, that when you're adding fractions, a over b plus c over d is actually equal to ad plus bc over bb. That is a mathematical definition of adding fractions. So what happens, you kind of do this kind of a cross multiplying here. Not cross multiplying, but multiplying across. It's not the same as cross multiplying. That's something a little different. So you have the butterfly looking thing right there, right? So again, it's butterfly. And then on here, down where the butterfly tail would be, you multiply across. So you're going to get a times d, which is ad, b times c, which is bc. Keep the order. The order matters. And then b times d is bb. So that's what I'm doing here. So how does this come in? I do 1 times 64. I'm going to get 64. And I'm going to do 1x squared times 1 is going to be x squared. And I'm going to do x squared times 64 is going to be 64x squared. So that's my numerator. On the denominator, I'm going to have 1 times x is just going to be x. 1 times 8 is just going to be 8. And 8 times x is going to be 8x. Hope you could read this. I'll write it over. It's an 8x in the bottom, right? So we have this complex fraction. And somebody is like, well, mister, this doesn't necessarily help. Well, it's about to help, I hope. So what happens now is this here bar is division. So what you really are doing here is, well, two ways. You can just multiply by 64x squared if you want, but you can look at it as a division. So what I have here is I have 64 minus x squared over 64x squared, and x plus 8 over 8 plus x, x plus 8 over 8x. And so if you look at that as a division, what you really get is you are having 64, all right, minus x squared over 64x squared, and the denominator is you're dividing by that, so it's going to be x plus 8 over 8x. Do KCF, all right, do KCF, and so you're just going to get 64 minus x squared over 64x squared times 8x over x plus 8. There's no easy way to do this problem. There's 3 different ways of looking at it, and all the ways share something in common. You got to factor. So again, this is difference of squares. So you have, what you're having here is you have a squared minus b squared. In this case, what you have is a squared minus x squared is going to be equal to, as we know, a minus b times a plus b. So 8 is going to be your a, so it's going to be a 8 minus x times 8 plus x. All right, so what we have here, by this concept, what I have here is I have 8 minus x times 8 plus x, all right? 8 minus x times 8 plus x. And in the denominator, I still have my 64x squared. All right, so I need to erase this now. And so I still have this here, 8x over x plus 8. Well, x plus 8 is the same as 8 plus x, so that cancels out. 8 into 64 goes 8 times, x into x squared goes x times. And so what I'm left with here, my answer is just going to be, as we saw before, 8 minus x over the x that's left over. All right, so that's my answer. And I know that was fast, but the benefit of a video is you can slow down and you can rewind, all right? So that's going to be 4A. All right, so 4A. And I'm going to stop this particular video here.